Let us start lecture 12. In lecture 11, we have learned this triangle delta Z0, K and E0, where this I can write minus NF is 0, delta 0 equal to minus RT ln K, and this one would be NFE 0 equal to RT ln K. So, this is the relation between all three quantities. Now, we will go ahead with this triangle and try to see if we can have some sort of correlation between potential, cell potential or the redox reaction potential with the equilibrium constant. Now, to start with, since we are talking about n, we are not fixing what is that value of n. The n could be, for example, Ag plus E equal to Ag, where n equal to 1, zinc plus 2E equal to zinc, where n equal to 2. We can have Fe plus 3 plus E equal to Fe plus, where n equal to 1 again. Even we can have this relation where n equal to 4. And we have taken 4 reduction reaction, and there is one more reduction reaction which we call it H2, where n equal to 2. Interestingly, if I write this way, then n equal to 1. We will see later on that whether you take this reaction or that reaction, whether you take this reaction or this reaction, it does not matter, you will get the same potential value. But from the reaction, since here 2 electron is involved, so that is what n becomes 2, and here 1 electron is involved, that is what n equal to 1. But both the cases, if the concentration of hydrogen ion remains fixed and if the hydrogen gas pressure is maintained at 1 atmosphere pressure, then both the reactions, it will lead to same potential of that particular electrode. And this reaction is also called hydrogen evolution reaction. Or it is shortly called as HER, HER, which is hydrogen evolution reaction. So, this is very important reaction in electrochemistry. Now, let us start with this. Okay. Since we cannot write K because we are taking non-standard values, that is what we write Q, reaction quotient. And this will be standard when this goes to equilibrium, and that time this K becomes 1, this Q becomes Q, and this becomes my standard change in free energy. Now, we can write it as minus NFE equal to minus NF E0 plus RT ln activity of C to the power C, activity of D to the power D, dBT of A Now, this is almost similar like now, where C equal to 1, D equal to 1, A equal to 1 and B equal to 1, as well as that time C goes to copper, D goes to zinc plus plus, A copper plus plus, B equal to zinc. So, like this A plus B equal to C plus D. I am trying to correlate electrochemistry with the chemical reaction. Now, since we are not specifying here the number of electrons associated with this particular process, n equal to 2. Why? Copper plus 2E equal to copper, since our convention is we will always take reduction reaction, and zinc plus 2E equal to zinc. So, the n becomes 2, and since we are taking n equal to n, so then my reaction pattern would be A n plus B equal to A plus B n plus. So, that case so exact this kind of similarity, if you see this and this two, and then of course, these two, they are quite similar, only thing is the numbers are changing. So, if we take this, then we can write this equation. Now, from this I can write E equal to E0 plus RT NF ln. Now, since we are writing with reference to this reaction, A B n plus A okay. So, this becomes like this. So, I have to put minus here, because this minus would go and the minus would come here. Now, if we take A and B are pure metal, that case A equal to A B, I can write it as this. So, my equation becomes E equal to E0 minus RT NF ln A B n plus n plus. We can write So, we are just changing this positive sign, we are changing denominator and numerator, and then accordingly we can change it. So, this is a very important relation. Now, from the look of this, who have little idea, he will say that this is nothing but Nernst equation. Now, we would look beyond this Nernst equation, would try to see this is for the overall reaction. Now, we will try to see what happens on the one beaker and what happens on the other beaker. Now, if we write this thing in terms of copper and zinc reaction, So, then we can write E equal to E0 plus RT 2F ln A copper plus plus zinc plus plus. So, that time N becomes 2 for this reaction. Now, let me see 2 cell, this is my salt bridge, this is a copper terminal, zinc terminal, copper sulphate, zinc sulphate. So, we have some activity of copper plus plus ion, activity of zinc plus plus ion. Now, if I try to look at the reaction copper plus 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 2E equal to copper, this is also electrochemical reaction. For that also we can construct equation like this. So, that would become E equal to E0 plus RT 2F ln A activity of copper plus plus activity of copper. Now, this is a relation for copper side, and for the zinc side this is copper side, and zinc side I can write where the relation reaction is zinc. Now, both this, now look at this, let me look at this. So, this relation if I see, copper plus plus is nothing but oxidant, and then it goes to reductant. How do I know that oxidant and reductant? Because again go back to hydrogen, this relation, and where we know that hydrogen gas is a very good reducing agent. That is what in some cases when we try to avoid oxidation of metal during sintering of some metal, we do purge hydrogen gas. So, the hydrogen gas actually reduces the oxides that are forming on the top surface of that metal. So, hydrogen is a very good popular reducing agent. So, this becomes my reductant. So, reductant would always get oxidized. So, reductant minus E equal to H plus. So, this becomes my oxidant. So, this is oxidant. Similar way, if you see that here the ion is accepting electron and forming reductant. So, the oxidant can only get reduced. So, our convention is fine. Now, from this can I not write E, since I am converting copper plus plus to copper. So, I can write copper equal to E0 copper plus plus copper plus RT 2F ln A copper plus plus activity of copper. In general, can I not also write I can also write this. This is a generalized form. Now, instead of this, I can also replace this with concentration of ox and concentration of red if I see that the solution is dilute. So, in case of dilute solution, A becomes concentration. Activity becomes concentration, because that time activity coefficient goes to 1 in case of dilute solution. Dilute solution, extremely dilute case of course, but in general we can take it as a kind of simplification. This is valid in case of ideal case, and ideal situation can arise when the system is dilute, because the interaction between the molecules or the species would be minimized. And what do we mean by dilute or ideal system? Ideal system is the interactions between the species is nil, that means there is no interactions. So, that is possible in case of dilute medium. So, I can write E equal to ox red equal to E ox red plus RT 2F. Now, instead of 2 I can generalize NF ln A ox red, or I can write so these two are the generalized statement of Nernst equation. Why you are writing ox and red? See, this is oxidant, this is reductant, which is copper, and similarly we are writing this, and from this we are writing this, and these are coming. This is when we do not know whether the system is dilute, and this is when the system is dilute. Now, similar pattern we can write in case of zinc side. Zinc side we can write E zinc plus zinc equal to E 0 zinc plus zinc plus RT 2F ln, and the copper side is since we know that copper is pure and zinc is also pure in the metal part, this goes to 1, this goes to 1. So, then we are getting only this term and only this term. Now, this side is positive, this side is negative as per our observation that the current is flowing from copper side to the zinc side. So, then the potential difference would be, which is nothing but E 0 equal to not E 0, because we are not specifying that whether the system has reached a standard situation, because the activity of copper plus plus and activity of copper zinc plus plus may not be 1. So, then this becomes E which is nothing but or we can write this is the same one what we have seen here. So, we can also get to the same equation considering the individual cells or considering individual hub cell. So, this relation will enable me to find out E as a function of concentration of copper plus plus and zinc plus plus. This is extremely important statement. The E cell would be function of concentration of oxidant or reductant. Since this is a fixed quantity which is 25 degrees Celsius, 1 atmosphere pressure, in case of this copper zinc system, we have this to be 1.1 volt and the hub cells are E 0 copper plus plus copper equal to 0.34 and E 0 zinc plus 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 zinc equal to minus 0.76 volt. And as we have already mentioned that we would all the time talk about the reduction process, and these entire relations are on the basis of reduction, because whenever I am writing ox slash red, that means ox is going to red, it means that ox red, it means that ox going to red, or we are having reduction. This is important. So, reduction potential on one hub cell is this and reduction potential of other hub cell is this. And also this relation tells me that what would be the cell potential if we change the concentration. Now, if we make it 1, this goes to 1, this goes to 1, then of course, E becomes my E 0 cell, which is the standard potential difference. This also becomes delta Z 0, because we are considering the standard value. Once we know this, now we have to look at the value, the quantification. Now, in order to quantify, since we have already told that Z 0 H plus, or we can tell it as mu 0 H plus equal to 0, 25 degrees Celsius 1 atmosphere pressure, then let us look at hydrogen evolution reaction. Now, in this case, let us say the hydrogen gas which is evolving from this reaction is maintained at 1 atmosphere, and this is also following this route. You can write E H plus half H 2 dilute, and if we consider it to be concentration of H plus ion and pressure of H 2. Since we have considered this is to be 1 atmosphere, so this turns out to be plus H plus. We have to find out this quantity. Since we know this, the another convention is 1 atmosphere pressure 25 degrees Celsius 0. So, if we both the quantities are 0, then for this reaction free energy change delta Z 0 would be mu half H 2 minus mu 0 H plus equal to 0. Now, delta Z 0 equal to minus NF E 0 n equal to 1 for this reaction, n equal to 1, F is equal to 96500 into E 0. So, this is 0. So, E 0 equal to 0. This is interesting. The standard reduction potential of hydrogen evolution reaction is 0. So, this goes to E H2 equal to 0 plus R T F ln H plus. Now, ln H plus I can write in this form minus R T into 2.303 by F log H plus. I can write 8.314, 298 Kelvin, 303, 500, so I am taking minus here in the bracket. So, I am taking another minus. So, if you remove the bracket, it would become plus. So, E H plus half H 2 equal to this. So, if I calculate this, let me calculate. .314 into 298 into 2.303 divided by 96500 equal to this becomes this. Now, interestingly, minus log H plus is nothing but pH. So, I can remove this term, I can have pH. This is a crucial relation also, we will use this relation. Now, interestingly, if we have this reaction, would there be any change in this reaction in this particular equation? Let us see. So, that time E H plus H 2 equal to E 0 2 H plus H 2 plus R T 2 F ln H plus square P H 2. So, this becomes pH 2, this is 1. So, it becomes, this should be also 0, because in this case this half term will go off and then finally, we will see that E 0 becomes 0. So, this is 0 plus R T 2 F and this 2 I can take it out ln H plus. So, this 2 gets cancelled, finally, we get again if we put those values 0.0591 pH. So, this reaction and this equation, both the equations are same. So, if we go and look at this, we said that both the reactions have the same electrochemical potential. So, it is also showing that they are same electrochemical potential and their slopes are also same. So, let us stop here, we will continue our discussion on electrochemical nature of corrosion and also the associated thermodynamics of corrosion. Thank you.